So let's walk through this process of writing a custom policy by looking at a specific scenario. So commonly in Amazon, it's an issue where a public AMI will be created. And if you're unfamiliar, an AMI is a snapshot of a running instance. And you can use these snapshots to create multiple other instances. It's generally a best practice if you have like a golden image, for example. It's a very common practice at scale. But if these images become public, they could inadvertently expose sensitive credentials or data. So we want to avoid this. So let's write a policy that would detect this. So the first thing we start with is an example resource. So this resource itself is an Amazon machine image, and we get all the context around, what type of hypervisor it is, what's the ID, who owns it, what's the kernel, and all of this context around the AMI. And the logic that we want to look at is, the public attribute should be set to false. And then we only care about AMIs that we own. Because in an account, you can have AMIs owned by other organizations. Like, for example, Ubuntu is owned by the canonical owner. So in this specific scenario, this is actually the Ubuntu image. But the account ID attribute is the account ID where the AMI actually originated from, which is the account that we're scanning. So we want to make sure that those match up, because we wouldn't be scanning an account that is owned by an organization like Canonical. So we use this logic to build it into our policy. So our policy is just a Python function taking an argument of a resource, and we're just checking these attributes based off of the logic that we just discussed. So we're saying public is not true, and the account ID is equal to the owner ID. And this would alert on anything that we're scanning, on any accounts that we own. If we wanted to restrict it to certain accounts, we would just say, resource account ID is in our account ID list, which we can define as another Python variable. And we can test this as well. So what we can do is we can put all of these attributes in place to mimic a non-compliant AMI. So if you look closely, you can see public is set to true, and the account ID and the owner ID are equal. So when we run this, we see on the bottom that this public AMI check passed, meaning we have confidence that our policy is going to work when we actually deploy this. So after you save this rule, a couple seconds go by, we run a scan on all the AMIs in your account, and then we see that, okay, now we found 3 AMIs, 2 of them are public, and 1 of them is not public, and this is compliant. So we can take action however we want, or we could write an automatic remediation that would just go ahead and fix those. And I'll walk through how that works next. So for automatic remediation, what we want to do is, maybe you don't want an analyst to have to go out of bound and fix this resource manually. We want to just fix it with code. So we can do this. So looking at another type of resource, let's take an S3 bucket, for example. Let's say we want to prevent these S3 buckets from being publicly accessible. There's a check that Amazon added somewhat recently that allows a protection to be put in place that would actually prevent the bucket from going public. So in this specific scenario, this resource doesn't have that set. So let's look at an automatic remediation that would actually set this. So in the policy editor where I was before, if you kept scrolling down past the tests, you would see this option to add a remediation ID. And the remediation ID has a set of parameters that determine how this option should be set. And if we look a little bit under the hood, we see that this is, at the end of the day, just a Python function that's running. So this is the actual remediation. This is how it looks. And we can see that these parameters get passed through an actual API call to put public access block. And then to understand a little bit deeper how this works, this workflow can be applied across resources in all of our different accounts or regions. And this helps a ton with centralizing all this logic into a single place for all of our accounts.